Hello, this video is for Chapter 3, Lesson 5. It's titled Solving Inequalities Using Multiplication or Division, where our objective is to solve inequalities using multiplication or division. Our review vocabulary is inequality and equivalent inequalities. So in the last lesson, Lesson 4 of Chapter 3, we were solving inequalities using addition or subtraction. And we found that solving inequalities was a lot like solving equalities. We're just dealing with a different sign, right? These greater than, less than, greater than or equal to, or less than or equal to signs. So now we're going to see how is multiplication and division, or how is solving inequalities with multiplication and division, how is it similar to solving equations that use multiplication or division? And is there any difference? So we'll start off with our geese migration here. Some flocks of geese can fly nonstop for up to 16 hours. So it's not exactly 16 hours, it's up to 16 hours. It could be less than 16 hours. And whenever we have phrases like this, for up to, that implies that we might be using an inequality as opposed to an equality. In this time, a flock can migrate as far as 848 miles. Not necessarily exactly 400 or 848 miles, but up to. So again, this kind of implies an inequality as opposed to an equality. At what average speed can such a flock fly during migration? In example 3, you'll see how to answer this question by solving an inequality. As shown below, when each side of the inequality, 2 is less than 8, is multiplied by a positive number, the inequality remains true. So we see here the first one on the left, 2 is less than 8. We're going to multiply it by a positive number. In this case, they're multiplying by 4. So 4 times 2 is 8, and 4 times 8 is 32. And 8 is less than 32, just like 2 is less than 8. So notice that the sign has remained the same all the way throughout. However, if we look at the next sentence where we left off reading, when each side is multiplied by a negative number, the inequality sign must be reversed. So we take that same 2 is less than 8, and this time we're going to multiply by negative 4 instead of a positive 4. And we'll see that negative 4 times 2 is negative 8, whereas negative 4 times 8 is negative 32. And we end up with negative 8 on the left, negative 32 on the right. We know that negative 8 is greater than negative 32, so we need a greater than sign. But we started with a less than that sign. So in order to make the inequality true, that is to say, in order to have the correct symbol there between the two values, we had to flip the sign, or you might say reverse its direction. These examples suggest the following rules for solving inequalities. And what are those following rules? Those following rules are the multiplication property of inequality. So in words, we say that multiplying each side of an inequality by a positive number produces an equivalent inequality. Boy, a bunch of EQs in there, right? Gets like tongue twisters. Now, multiplying each side of an inequality by a negative number and reversing the direction of the inequality symbol, so we have to reverse it when multiplying by a negative number, produces an equivalent inequality. In algebra, we would say that if A is less than B and C is greater than 0, so this is a positive number, right? Then multiplying multiplying both sides, we'll just call it that, multiplying A by a positive and B by a positive, notice that our symbol remains the same. I better circle it so we don't think that that's part of the symbol there. So notice that the sign remained the same. However, if A is less than B and C is less than 0, that is to say that C is a negative number, then whenever we multiply both sides by a negative number, notice that the signs changed. First we had a less than, and now we have a greater than. The direction of it is kind of, and they even use the word direction here, so reversing the direction. So we have to change the sign, or we have to flip the sign. So here we have an example 1. Here's solving an inequality. using multiplication. So here m is being divided by -3, and it's greater than 3. So in order to get rid of this -3, well, the m is tied to the -3 through division. The opposite operation is multiplication, so we're going to multiply by the very number we wish to get rid of, which is -3, and what we do to one side, we're going to do to the other. Sounds familiar, don't it? That was kind of like solving equalities. So multiplying both sides by -3, these two -3's cancel each other, but notice that we've already reversed the sign right here. The minute that we multiplied by the -3, we reverse the sign. So that sign's going to come down here to our final line. The -3's are going to cancel each other, leaving us just m. -3 times +3 is -9. So we have m is less than -9. Division. How's division work? Well, we're going to find it's pretty much the same thing. We're going to have to flip the sign. And it makes sense, too, that if we have to flip the sign for multiplication, and since division's the inverse property of multiplication, it's probably going to affect the division as well as the multiplication. So the rules for solving an inequality using division are like the rules for solving an inequality using multiplication. Division property of inequality. In words, we say dividing each side of an inequality by a positive number produces an equivalent inequality. Dividing each side of an inequality by a negative number and reversing the direction of the inequality symbol produces an equivalent inequality. So like we had on the last example here, a is less than b, and if c is greater than 0, that is to say it's a positive number, then dividing both sides by a positive number is going to keep the sign the same. However, if a is less than b and c is less than 0, that is to say that c is a negative number, z is a 0 number, but c is a negative number, then if we divide both sides by a negative, then we're going to have to flip the sign. You notice that the sign changes direction in this case. All right, so just remember that if you multiply, so sum it up, the best way to put it without all of this, these fancy words here is, if you multiply or divide by a negative, you have to flip the sign. That's pretty much the rule. And also keep in mind that the multiplication and division property of equality are also true for the inequalities involving greater than, less than or equal to, and greater than and equal to. The idea is that it applies to all four of the inequality signs. So here in example 2, -10t is greater than or equal to 34. Well, the -10 is tied to the t through multiplication. The opposite operation is division. Remember, all fractions are division problems. We're going to divide by the very number we wish to get rid of, which is -10. And what we do to one side, well, we do to the other. Now, we can go ahead and flip the sign at that point. Notice the sign's already been reversed. -10's cancel each other, leaving us with just t on the left. And -34 divided by, positive 34 divided by -10 equals a -3.4. So we end up with t is less than or equal to -3.4. We should have a checkpoint here. And looks like we've got all positive numbers here in the first one, and a negative number here in the second one. So let's go ahead and do one that's positive and one that is negative. So we'll do problems 1 and 2. So n over 6 is greater than 7. We'll rewrite the problem there. And the n is tied to the 6 through division, so the opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is the 6. And what we do to one side, we're going to do to the other. The 6's are going to cancel each other, and that leaves us just the n. We multiply by a positive, so the sign's going to remain the same. And 7 times 6 is 42. So n is greater than 42. For number 2, we have t divided by -4. And this is less than or equal to a positive 8. So notice the negative numbers show up. Now, if the negative were the 8 over here, and some problems will try to trick you like that, they'll put a negative over here that's not tied to the variable somehow, and they'll see if, oh, there's a negative number, I got to switch the sign. So be careful that you're only changing the sign if you're multiplying or dividing by a negative number. It's not, is there a negative number involved in the problem? It's, the question is, are you multiplying or dividing by a negative number? So in this case, we're going to multiply by -4. And what we do to one side, we're going to do to the other. And the -4s are going to cancel each other, leaving us with just t. We did multiply by negative, so we need to reverse the sign. And 8 times -4, what's a positive times a negative? So the answer is going to be negative. And 8 times 4 is 32. So t is greater than or equal to -32. And now we come to our geese problem here, right? Write and solve an inequality. So we need to find the average speed at which the flock of Canada, I keep wanting to say Canadian, it's Canada, at which the flock of Canada geese, described on page 144, that was our first slide that we started with, can fly during migration. So our solution is we're going to let S represent the average flight speed. So S is representing our average flight speed. We're going to write a verbal model. Well, our flight time times whatever our average flight speed would have to be less than or equal to the maximum flight distance. So we're going to substitute in what we do know. We remember that it said 16 hours. They can fly up to 16 hours. So this is where we're getting the 16. That is the flight time, 16. And the average flight speed is the unknown, S, because time times speed equals distance, right? If you think about it, if we think about that, let's, if we have time times speed and distance, if we were talking about an equation, this is where they're getting their numbers. Time times speed equals distance. For instance, if you drove 2 hours at 60 miles an hour, you would go 120 miles, right? So one strategy of mathematics is to create an easier problem, something that you're familiar with, so that you can then apply it to the situation that we have here. So this is how we're getting our numbers. This is how we're setting it up, right? So that's how we know that it's set up. And now the 16 is tied to the S through multiplication. So we need to go ahead and divide by 16. And what we do to one side, we do to the other. 16s will cancel each other, leaving us with S on the left. And 848 divided by 16 is 53. Notice that the sign stayed the same because we never multiplied or divided by a negative number. So the sign never flipped. And our final answer is S is less than 53. So the flock of Canada geese can fly at average speeds of 53 miles per hour or less during migration. That means that they can't fly over that. If you think about it, they flew faster than that. If their average speed were faster, then that would make the flight distance even longer. And we know that they said that they could only fly up to 848 miles. So we know that the average speed has to be less than 53. In the real world, geese migration. In North America, not all geese migrate. About 3.6 million resident geese live in urban and suburban areas, such as parks, throughout the year. I suppose that's because there's people to feed them. Resident Canada geese outnumber migrating Canada geese. Write an inequality that represents the number of migrating geese and resident geese. So let's use a couple variables to represent this. We can say that resident geese, we'll use an R for resident geese. And where are those migrating geese? Yeah, here's the migrating ones. We'll call that M. So it says that there are more resident geese, correct? Find that in there. I think they use the word outnumber, isn't it? Right there it is. Resident geese, here, R. Resident geese outnumber migrating Canada geese. So that means there's more of them, right? So the number of resident geese is greater than the number of migrating geese. So we would say R is greater than M. And that brings us to our guided practice for this one. Vocabulary check. Which property would you use to solve the inequality? Negative 7y is less than 49, less than or equal to 49. Well, since negative 7 is tied to y through multiplication, we would use the division property, right? We actually divide by negative 7, and the sign would have to flip, etc. Right? On the next one, explain how to solve, or explain how solving 2x is greater than negative 14 is different from negative 2x is greater than 14. Well, notice that the first one, the leading coefficient of the variable x is a positive number. So if we solve this, we'd have to multiply or divide by a positive. That means the sign would stay the same, correct? However, on the next one here, the leading coefficient of the variable x is a negative number. And that means we'd have to divide by a negative 2 to isolate that x on the left. And that means that the sign would have to change. So how the two of these would be different is that the first one, the sign would remain the same because we don't have to multiply or divide by a negative. However, on the other one, we would have to flip the sign because it would involve dividing by a negative. On the skill check, solve the inequality and graph and check your solutions. And we know about graphing and checking solutions because we've done this before in other activities. So let's select let's go ahead and do one that has a negative number and needs multiplication. Let's select another one that has a negative number and needs division. And then let's select one that needs division but does not involve negative numbers. So we're going to do 3, 6, and 9. So 3 is v over negative 2 is less than negative 8. So we're going to have to multiply times the negative 2 to get rid of that negative 2. And what we do to one side, we're going to have to do to the other. The negative 2's are going to cancel each other and leave us with v. We did multiply by negative, so we have to switch the sign. Negative times negative is positive, and 8 times 2 is 16. So we get v is greater than 16. So pick a number greater than 16. Let's go with 20. Let's say that v is equal to 20. We'll plug in 20 there. So 20, I'm plugging in for v, over negative 2. What's that equal? It equals negative 10. Is negative 10 less than negative 8? Indeed it is. So we could check that out. Oh, and they said for us to graph it, right? So if we were to graph it, we would have to have our line, and then we would have 16, and it should be an open dot, and since my variable is on the left, I can use it as a cheat to tell me which way the line should go on the graph. And so I would graph to the right because the arrow is pointing to the right. And then if I pick a number that's in that area, remember I picked 20. That was a number I chose to plug it in and test it. All right, so we've done number 3, graphed it, checked our answer. Let's go ahead and do number 6. So I have negative 6s less than equal to 54. So the negative 6 is tied to the s through multiplication. I'm going to use division to undo it. I want to divide by the very number I wish to get rid of, and what I do to one side, I do to the other. The negative 6 are going to cancel each other, leaving me with just s on the left. I did divide by negative, so I need to switch the sign, right? And positive divided by negative is negative, and 54 divided by 6 is 9. So s is greater than or equal to negative 9, so there's our negative 9. We do have the equality concept, the half and equal sign, so we know that should be a solid dot. My variable is on the left, and so the arrow is pointing to the right. Remember, we can only use that little trick of using the inequality symbol to tell us which way to graph our answer if the variable is on the left. And then I can pick a number to test. Well, what about 0? 0 might be a good one to plug in there and check. So let's plug in 0 for s. So 6 times 0. If I say that s is less than 0, then 6 times 0, or negative 6 times 0 is 0. And is 0 less than or equal to 54? Indeed, that checks out, so that would be correct. And then finally on our last one, let's go ahead and work that one. We have 3r is greater than or equal to 21. So the 3 is tied to the r through multiplication. The opposite operation is division. Remember, every fraction is a division problem. And we're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we have to do to the other. So the 3's cancel each other, leaving me with r. I multiplied by, or divided, that is, by a positive number, so the sign's going to stay the same. And 21 divided by 3 is 7. If we go ahead and graph this and we find 7 on our number line, and we want a closed dot, right, because we do have the equality concept, the half and equal sign. It is greater than or equal to, so 7 could be an answer. And then we want to go to the right on the graph. So let's pick a number that's down here to the right of 7. That'll work well. I think 10 might work well. So let's plug in 10. 3 times 10. We're just substituting 10 for the r. And where do we get this 10? Because this 10 is part of the solution set for this inequality. So it's over here in this highlighted part of the number line. And that's not a negative there. That's just underlining that we're going to do number 9. So 3 times 10 is 30. Right? So is 30 greater than or equal to 21? Indeed it does. So our answer checks out on that. And we've gone for a bit. We're up over 21 minutes. I think I'm going to skip the training question for today. We'll skip that part of the guided practice problem. All right, so that pretty much covers everything for solving inequalities using multiplication or division. And so if we think about it and we recap, basically solving inequalities is just like solving equalities. Working with problems that have the less than, greater than, less than or equal to, greater than or equal to, those are inequalities. Solving those are just like working with problems that have an equal sign. The only difference is that if you have to multiply or divide by a negative, then you're going to reverse the sign, which is what we found here in the multiplication property of inequality and in the division property of inequality. So just remember that if you multiply or divide by a negative number, be sure to change the sign. All right, so thank you.